Academic Algebra 2, Chapter 5, Section 1 lecture. Okay. Cool. Okay. All right, so we're going to use the product rule to simplify these exponents, okay? So we want to rewrite these two expressions as one exponent, okay? How do we do that? How do we do that? What's the general rule we use? This is going to get a gold star. Anyone remember from Algebra 1? A lot of blank stare. Okay, a to the b times a to the c equals a to the b plus c. Okay? A to the b plus c. Stuff never goes away. Stuff never goes away. Okay? All right, so if you have two numbers with the same base, the base is like the regular number, so 2 is the base there. A to the b times a to the c equals a to the b plus c. Okay? So two numbers, two exponents with the same base and different exponents, right? To combine them into one exponent, you just add the exponents. To combine them into one power, I guess. Right? So for 2, what would that become? 2 to the 3 times 2 to the 4 equals 2 to the 3 plus 4. Thank you, Mr. Rodman. Okay, I can see that. All right, this generalizes when we have 3. So m, this is technically m to the 1, right? M to the 1 times m to the 9 times m to the 7 equals m to the 1 plus 9 plus 7 equals m to the 17. Huh? Yeah. The way these problems get hard, if you guys remember, these problems get hard when it's like, okay, use like all 4 of these rules on like this huge thing, right? Like D's getting a little big, D's getting a little big, right? Right? What about this one? What about C? So the way we do these, right, is reorder it, right? Multiplication is commutative, so this is the same thing as -6 times positive 6 times x times y times y, right? See what I did there? Okay, -6 times 6 is -36. Right, and times x, and y times y, that's the same thing as y to the 1 times y to the 1. So that's going to be y to the 1 plus 1, y squared. Feeling okay about that? You guys hear me? Good stuff. Okay, D for D, right? Same deal, same deal. Okay, so we can reorder. Let's put all our constants, -3 times -5. Let's put the constant numbers at the front, and then times a cubed. Let's put all the a's next to each other. B squared times b. That's technically a b to the 1, right? Okay. So you guys see how I just reordered everything? I put all the light bases together. So -3 times -5 is 15. What would a cubed times a cubed be? A to the 6. And then quincomma would be squared times b. That's a 3. Yeah, that kind of looks like a 0. B squared times b to the 1 is. Good job. Okay. Can we move on to A? Can we move on to A? Evaluate or simplify each expression. All right. So does anyone remember what 2 to the 0 is?
1.
Yep. So a number, okay, so gold star here. A number raised to the 0 equals 1. Gold star with an asterisk. What's my asterisk? There's one number. There is one number that when you raise it to the 0, it does not equal 1.
Is it 1?
No, 1 to the 0 equals 1.
0.
Yeah, 0, yep. 0 to the 0, anyone know what that equals?
Oh.
Stealing my thunder. I was going to leave the class with a cliffhanger for that one. Good job. Hey, round of applause for Charlie. TJ gets the first. I get it. Good. So we learned something over Zoom during Algebra 1. So 2 to the 0 equals 1. Negative 5 to the 0 is also equal to 1. Negative 10 to the 0 equals 1. Okay. 2x plus 1, what's that equal to? That's also going to be 1, but, okay, I'm going to do, right, so let's think about this. If I have x equals negative a half, the inside is 2 times negative a half plus 1, which is negative 1 plus 1, which is 0. So it's equal to, it's undefined if x equals negative 1 half. Right? Otherwise, it's equal to 1. Right, can you see that? So as long as our x is not equal, right, because if x is equal to negative 1 half, the stuff inside that parentheses is equal to 0, and 0 to the 0 is undefined. Otherwise, it's just 1. Right, good way to think about this, like in general, so like going back to that first one, 2 to the 0, this has to equal 1 because 2 to the 0 times 2 to the 1, right, that's going to be 2 to the 0 plus 1, which equals 2 to the 1, which equals 2, okay? Right, so 2 to the 0 times 2 to the 1 equals 2. We divide both sides of this by 2, right? There's a little, like, mini proof, I guess, that 2 to the 0 equals 1, okay? Using the product rule, using that rule up there. Right? And so if this rule holds true, then it necessarily, right, of logical necessity, it follows that 2 to the 0 equals 1. Okay? Cool, cool. Anyone remember the quotient rule for exponents? Yeah, subtract. Subtract. Yep. So, gold star this, a to the b over a to the c equals a to the b minus c. Okay. A to the b minus c, okay? Hey, can you put your phone away, please? There you go. All right. So x to the 8 over x to the 3 equals what, Paige? X to the 8 minus 3. All right, B for B, okay? For B, I encourage you to rewrite this as negative 10 over 2 times y to the 11 over y to the 7. Okay, is anyone confused on how I can rewrite it that way? No, so then it becomes, right, negative 10 over 2 is negative 5. Let me write that better. Right, and then y to the 11 over y minus 7 is y to the 11 minus 7. Or just y to the 4th. Okay about that? C. you to write this as 15 over 9 times, let's put my x's together in one fraction, x over 6, x to the 6 over x, times y to the 5th over y cubed, right? So the basic rules, the general rules we're using here are not too difficult. Where people are going to get these wrong is when there's just a lot going on in these problems and you're going to get mixed up and make a mistake, okay? Alright, so does anyone not see how I could rewrite it that way? I just rewrote it as the product of three fractions. And then 15 over 9 is 5 over 3, 5/3. Okay, x to the 6 over x, and what's that? Yeah, x to the 5th, yeah. And then Danny Hall, what's y to the 5th over y cubed? Sweet. Alright, same thing for D. For D. That's 36 over -4 times a squared over a over b times c12 over c. I encourage you to rewrite it that way. Right. Mathematicians like to break problems with many parts into problems with smaller parts, or many problems with one part, okay? Alright, so 36 over -4 is -9. A squared over A is what, Charlie? Just A, and then Sheldon, what's B cubed over B? Squared. Emily, what's C? 12 over C on 9. Yeah, good job, yeah. So, congratulations, you know how to subtract numbers in your head. Congratulations. Okay, we feel okay about that? So we have this page to fill out. Simplify and write using the positive exponents only. Okay. All right. How do I want to say this? All right. So the golden rule here, gold star rule here. How do I want to write this? Okay. So suppose C is positive. So let C be a positive number. Then 1 over a to the negative c is equal to a to the c over 1, which equals a to the c, okay? So you can just take negative exponents, flip it to the other side of the fraction, right, and then make it a positive, okay? Similarly, another way of writing this is a to the negative c equals a to the negative c over 1, which equals 1 over a to the c. And these should both get gold stars. I'm going to highlight them in my favorite highlighter color. Teal. Alright, so 2 to the negative 4, I rewrite that. Yeah, of course, yeah. Alright, ready? T to the negative 4, right? We rewrite that as t to the negative 4 over 1. And then we flip, right, that number down to the bottom. It goes parentheses squared, right? That's 1 over negative 3 times negative 3, which is 1 over 9. There you go. Move on to part C. Alright, not a bad idea to rewrite this as y to the negative 3 over 1 times 1 over y to the 6. Not a bad idea. Right? Then this first one here, right, that becomes 1 over y cubed. So our expression equals 1 over y cubed times 1 over y to the 6th. Okay. That's 1 over y cubed times y to the 6th. And using my power rule or product rule, that's 1 over y to the 9th. Right, anywhere we got lost? Okay, it's okay. Where did you get lost? Too many steps? I mean, okay, so it might have been easier. Maybe I just made this too many steps. The way I think, I like to use lots of steps. Do you guys see though, like you can do one step? All right, do you see, would it be easier for you to think like, okay, just take the y, move it to the bottom, and it becomes positive right off the bat? Is that easier for you to see? Okay, I'll just do it that way, okay. Sounds good. Yeah, cool. All right, yeah, that was probably too many steps, sorry. But if this makes sense to you guys, I just feel like I'm skipping a lot, so I don't want to confuse you guys. Usually I get into trouble teaching when I like skip a bunch of steps, so. But this might be an exception to that rule. So that's better? Yeah. Yeah, so you can just think about it this way. Let me make sure I get that on camera. Okay, cool, it is on camera. Sweet. All right, 2a to the negative 3, Maggie. What's this equal to then? Yeah. You don't flip the 2, you just flip the. You don't flip the 2. So the negative 3 is only applies to the a. Yeah. So 2a cubed. Yeah. Stays. Yeah. Yeah. Right. To flip the negative, the 2 to the bottom, we'd need to have a negative 3 on the 2.
Only flip stuff that has
We can only flip stuff that has a negative exponent on it,
Gotcha.
right on that thing.
Gotcha.
Yeah, thank you for the distinction.
No,
Thank you for making distinctions. Yeah. All right. Max Finn. How do I do this one? Got to get rid of the negative exponents. Can anyone help them? Bonnie, can you take the AirPod Pro out? Thank you.
Add 5 to 2. So it'd be x to the 4th power over x to the 3rd.
Okay, yeah. So he whipped through that one. Yeah, he's doing well. There's multiple approaches you could take. That's right. You're correct. Yep. There's multiple approaches you can take. One approach is you can think, okay, I got to move my x to the 5th to the bottom. That becomes positive, right? And then I've got to take my x to the negative 2 down here and move it to the top. And that makes it become positive, right? So we can think we got to move this down, then move that up. right? Then it would become x to the 6th over x to the 5th, or x. Right, you guys see that? Is that confusing, how I just did that? Okay, cool. You could do it that way. Another way you could think to do this, let's start from the beginning. Another way is you can just add the negative 5 to the 4 right at the beginning. So that becomes x to the negative 5 plus 4 over x to the negative 2, which equals x to the negative 1 over x to the negative 2. That's another way of doing it. And then we just got to flip both of those, right? That becomes x squared over x to the 1, which becomes x. First line or the second line, you can do either of those. Yeah.
So you can add exponents still if they're negative, and you
Yeah,
have
we can still add them, yeah. Yeah, so we did here, right, we had to swap these around. Right. Does that second way make sense at all? Okay, cool. F. All right, so I encourage you to rewrite this as 12 over 4 times a over a to the negative 3 times b to the negative 3 over b cubed. Right, that gives us 3 smaller, simpler problems from our one big problem, right? Okay. All right, 12 over 4 is 3. Write that 3 here. 3. All right. Times. What do I do with that a over a to the negative 3? What does that become? Becomes
Does it become a to the 4th?
a to the 4th. Yeah. So I want to take this a to the negative 3, move it to the top, make it become a cubed. Okay. That becomes a to the 4. And then this last one is what's the b factor? Chris Collister, you know what that b becomes? B to the negative 3 over b cubed.
I don't know. I just thought they were
Yeah, 1 over b to the 6th. Yeah, so this b to the negative 3's got to move down, become b to the positive 3 on the bottom.
Wait.
That becomes 1 over b to the 6th. Then 3a to the 4 times 1 over b to the 6 is 3a to the 4 over b to the 6. Are we feeling okay about that one? Okay. All right. Good. All right. Let's do G. You guys want to do G? Oh, I'm getting big. Woof. All right. Right. I encourage you to split it into the constants and the each individual variable. So 20 over 2 times x to the negative 8 over x times y over y times z to the negative 13 over z. Right, so 20 over 2 is just 10, right? What does my pink part become? What do I got to do? So I got to take that x to the negative 8 here, move it to the bottom, make it x to the positive 8. So that becomes 1 over x times x to the 8, so x to the 9. Right, y over y is just what? 1, yeah, it's just 1. And then that red part, z to the negative 13 over z becomes what? Yeah, exactly. I got to take the z to the negative 13, move it to the bottom, becomes z to the positive 13. And then z to the 1 times z to the 13 is 1 over z to the 14. Okay. So if I multiply across the top, right, I get 10 times 1 times 1 times 1, so that's 10 over, and then I have x to the 9th, z to the 14th on the bottom. Okay, so okay about that one? You feeling okay about this? Good. Alright, here's a good one. Right? So I encourage you to rewrite this as, okay, multiply your constants together. 3 times -2. Okay. Times, multiply your a's together, a to the cube times a to the -4. Multiply your b's together, b times b to the -2. So we haven't actually done anything other than reordering all of our factors, right? We just reordered everything. Okay? Is that confusing us or no? Okay? And then, what rule should I use to combine some of these exponents? So that's going to be -6 right there, right? What rule should I use to combine? Oh no, -6. What should I use to combine these two? Yeah, the one where you add the exponents up, right? So a to the -1 times b to the -1. Okay. How do I get rid of those negative exponents in the a and b? What do I do? Yeah, so I put it over 1, and then I want to move this a to the bottom, it'll become an a to the 1. I want to move my b to the b to the -1 to the bottom, it becomes b to the 1. So that's -6 over ab. How do we feel about h? Is that okay? So they just have many parts. They're unlike God. God has no parts. These problems have parts. God has no parts.
Does it, like Jesus?
That's a really good question.
Is it
That's a
like-
good thought. That's a good
isn't
thing.
there technically
Isn't it
three of
like
them?
3 parts, 1 body?
Exactly, yeah. So the Trinity, the doctrine of the Trinity is, so yeah, that's the 3 persons of the Trinity. There's one God in 3 persons. The 3 persons are not 3 parts of God. They're 3 persons that share the same divine substance, okay? There, that's the Trinity. Okay?
Wait, so they share the same soul, essentially.
I started out right.
Different metaphysical terms, but yeah, you're on the right track.
It's 3 people.
3 persons, 1 substance. Yeah, that's it. Yeah. Take a metaphysics course if you want to know what substance means. Okay. We should probably come back and do these scientific notation problems. You just triggered me.
I did not mean to.
Yeah. Yeah. God, this divine substance has no parts. It's medieval theology. The medieval theologians and philosophers wrote about that. Anyway.
I guess I got it.
Okay, so can we do this? Are we okay to move on to 5A? Okay to move on to 5A? Okay, cool. Okay. 645,000. We want to rewrite. We want to write it in scientific notation. Okay. We want to rewrite it in scientific notation. So let me make sure the camera's pointed over here because I'm going to use the whiteboard for this. Okay, that's good. So scientific notation, numbers in scientific notation are written of the form, okay, think about the best way to do this. A times, okay, the asterisk means times, I'll do a dot, I'll just do a dot. A times 10 to the, let's call that K, okay? All right, where A is between 10 and 0, okay? A is between 10 and 0, and K is an integer. What are my integers again, right? -3, -2, -1, 0, 1, 2. So any non-fraction, right? Any non-fraction number. Okay. So how would we rewrite 645,000? How would we rewrite that in scientific notation?
6.41
Yeah, 10 to the 5, right? So it's going to be 6.45 times 10 to the 5. Okay? And to give you guys a little background on this, right? We need 645,000, right? We need that instead to be a number between 0 and 10. So we're going to want it to be 6.45, right? How do we go from 645,000 to 6.45? What do we do? What we've got to do is we've got to divide this number by 10 5 times, right? If you take a number, so 645,000, the decimal place is here, right? Right? This is technically 645,000.0, okay? To move the decimal place over to the left one time, we divide by 10, right? Then we divide it by 10 again, right? Then we've got to divide by 10 one more time, or not one more time. Then we've got to divide by 10 yet again, and then a 5th time, okay? That gives us 6.45. We want to move the decimal place, right? However many decimal places, right, we moved to the left, right? When we multiply a number back out, we got to get the original number we started with, okay? So I write times 10 to the 5, right? This tells the reader, okay, to get the original number back in regular notation, you take the decimal place, you move it back to the right 5 times, i.e., you multiply by 10 5 times, or 10 to the 5th. Is that a really weird explanation, or is it good? Okay, no, just blank stares, okay, cool. All right, is that okay? Is that like a decent explanation? Okay, I hope it is. So this is going to be, right, so your gold star rule here is a times 10 to the k, right? A is between 0 and 10. K is an integer. It can be negative, right? It could be negative, okay? So this one, it's, right, we've got to move to the left 5 times, so it's 6.45 times 10 to the 5th. What about B? I'm sorry, it has to be between 0 and 1. I'm so dumb, sorry. All right, not dumb, but I just forgot. I'm not dumb, I forgot. It has to be between 1 and 10, I'm sorry. Didn't realize, okay? So how do I get, so this, right, I've got to do what with the decimal point on B? I've got to get it between 5 and 6, right? So I need to move to the right 3 times, okay? So I need to move the decimal to the right 3 times, okay? So 1, 2, 3. So that's going to be 5.621 times 10 to the what? Does anyone know? -3, yeah, right? This tells my reader, this -3 tells my reader, okay, to get my original number back, you've got to move the decimal place to the left 3 times, i.e. you've got to divide by 10 3 times, or multiply by 10 to the -3, okay? You following that so far? Okay. And then going from scientific back to standard notation. Scientific back to standard notation, okay? C. 3.6 times 10 to the -4. All right. Whom have I not called on? Tegan. How do I write that in standard notation? Okay. Why don't you phone a friend? Yeah, so you're spot on. When you multiply, so going from scientific to standard notation, when you multiply by 10 to the -4, that means to go back to standard, you move the decimal to the left 4 times. 1, 2, 3, 4. Now it's right here. Anywhere there's an empty space gets a 0. Okay? So a negative exponent, let me highlight it, a negative exponent here on the 10, right? That means you move, so negative, move decimal place to the left. Okay, so the answer is 0.00036. There you go. There you go. And then D, Ava, what would I do for D?
Move the decimal to the right side.
Yeah, so now, right, so this is, right, my exponent's positive. So I move the decimal point to the right. To the right. Okay. So I do 1, 2, oh gosh. Do 1, 2, 3, 4, 5. Anywhere there's an empty space here, so my decimal point is now right here. Anywhere there's an empty space, I put a 0. So that's 950,000. How do we feel about this? Feel okay?
Right.
All right, cool. You guys want to spend like 10 minutes reviewing for the quiz? Or you guys just want to chill? You can chill or you can pay attention to me. All right, it's Friday, right? It's the last period on Friday. So go home, enjoy. Anyone go to the football game? Any
Not by choice.
fun weekend plans?